Good afternoon, everyone. This is G. Om Kedareshwar Kiran from Institute of Aeronautical Engineering College, Department of Electrical and Electronics Engineering. Today, we are going to explain about non-dual locus diagrams. What are the non-dual locus diagrams and their applications and their types of rows? Starting with dual locus diagrams. What are the dual locus diagrams? Let us know the locus diagrams. Dual locus diagrams are powerful tools for understanding the relationship between patterns. They provide a visual representation of how genes are linked and how recombination of event effects of transition traits. The presentation will explore the construction, interpretation, and application on dual locus diagrams. The locus diagram is a scientific diagram that can be used to analyze and stabilize the moderative oscillators of higher order system. Here, he is what is going to say is the locus diagrams are the breakage way of the point and the breakage way of the point of 2-second axis at an angle of 45 degrees. We can see the diagram on the left side. There are two breakage ways and the zero breakage way where constant k equal to 0, they have took the notations -2 plus 4j and -2 minus 4j. These locus diagrams are dual in nature, hence they are on a same axis. We can see the axis by k equal to minus infinity to plus infinity, because there are no 2-point ways for these dual locus diagrams, and these oscillators are in the higher order because it is in infinity. The units are taken in infinity. The locus diagrams and curves that are created by expanding a phasor diagram. We all know that what is the phasor diagram. The phasor diagram shows the relationship between the two parameters. In our subject, the phasor diagram, it can, for example, it will show the relationship between voltage and the current. They are used to determine the behavior of an RLC circuit when one of its parameter is changed while the voltage and frequency are kept constant. These voltage and the frequency are kept constant in these locus, non-locus of duality nature. The frequency of the voltage is also kept constant. The root locus technique is used to find the roots of characteristic equation and graphical techniques of plotting the locus of a roots in S-plane. The upper quadrant has been taken as the S-plane. So the graphical technique of plotting the locus diagram in the S-plane is the characteristic equation given in a system parameter is varied over a range. If we look at the diagram clearly, we can get about the dual locus diagrams. Now coming to introduction to dual locus diagrams. What are the dual locus diagrams and its introduction? In generally the AC electrical circuit, what is AC electrical circuit? Alternating current electrical circuits. The magnitude and phase of the current vector depends upon the value of RLC, resistance, inductance, capacitance. When the applied voltage and frequency are kept constant, means the voltage source which is applied and the frequency are kept constant, the path traced by the trimmer tips and the current vector, when the parameter of RLC is varied, it is called the current. We can see the diagram nearly stability boundary, and we are having the complex conjugate pair of roots, negativity real partial of decaying association. They are also a complex conjugate pair where it is the positive real parts of growing. In the middle of the axis, imaginary part where j equal to infinity or j omega, it is the stability boundary. On the left side, we can see the AC alternating, and the right side, there is a slow response of resonance where the positive roots are giving exponentially increasing output. The positive roots are in general, they are explanation a positive real output by increasing the value, and the negative real output exponential decay. The lines of the locus where the time constant of RLC parameter is varied, so it is called the current of the so it is called the current with path traced in terminus current vector. It also represents about the vector. Now let us take an example of RL circuit of the locus diagram. The locus RL circuit locus diagrams are useful in studying and understanding the behavior of RLC circuits when one of these parameters is varied, keeping voltage and frequency constant. In this unit, locus diagrams are developed and explained for series RC RL circuits and the parallel LC circuit along with their internal resistances when the parameter of R, L and C is varied, where resistance, inductance and capacitance got varied. The term circle diagram identifies locus plots of the either circulation semicircular and these defining equations in such as the semicircle diagrams are also derived in a unit for series RC and RL diagrams. In the both series RC and RL circuits, the parallel inductance and the capacitance circuit resistances are taken to be in a series with L and C to highlight the fact of the all partial L and C components will have the at least small value of the internal resistance. Here in the diagram, it is shown that the resistance and inductance are connected in series. The resistance voltage across the resistance is VR and the voltage across the inductance is VL. The total voltage is V equal to VR plus VL by applying the KVL. Let us take an impedance triangle, impedance locus diagram, where the resultant vector is impedance Z and the opposite side of it is XL and the adjacent side is R, where Z equal to R plus omega JXL, then the omega equal to 2 pi FC. If Y equal to 1 by Z, that equal to 1 by Z into E omega t, that equal to 1 by mod Z magnitude of z, where magnitude of z equal to r square plus jxc square. We can see here the locus diagram of admittance locus diagram triangle, sorry, semicircle. In phase with reverse when forming the reciprocal value, you get a negative sign where it is in downwards impedance and reactance. The admittance locus triangle where omega equal to infinity to omega equal to 0, it forms a semicircle. Now coming to the constructing dual locus diagrams. How can we construct a dual locus diagrams or what are the parameters in the dual locus diagrams? There are three types of constructing dual locus diagram types. Uh, First one is parenting genotypes. Start with a genotype of the two parent indicating the areas of each gen, and the second one is gamete formation. The gamete formation is nothing but the two axes of the planes where phase angle and the current of omega L and omega C are equal to 0. So the possible gamete produces the each parent considering the recombination of the axes, which is nothing but events. Offsprings genotypes means when the two dual networks of the locus diagrams are constructing, it can be linear or in non-linear by constructing the genotypes of offspring representing all positive combinations of x-axis and y-axis where omega and resultant vector is equal to 0. Now coming to the cal calculating recombination frequencies. These frequencies recombination of offsprings and non-recombinant offspring. Offspring with variable allele combinations of different parents and offsprings with allele combinations of identical. We can know that the frequency and the voltage of the given linkage analysis of locus diagrams is equal to recombination offspring by total offspring into 100 percentage. The percentage calculation here it is taken. We can see the left side the locus diagrams of genofits of locus diagrams and axes. The blue RYB phase represents and the green is given to the ground voltage. Now interpreting locus diagrams, linkage groups, gene distances, and recombination events. Here there are three R, Y, and B phases, three phases of linkage groups. that are linked together to form a linkage group indicating the proximity and gene distance recombination frequency in proportional to gene distance of allowing the creation of genetic maps. Recombination events present recombination offsprings in occurred during these periods. This A plus B is given to the blue of offspring of locust to red, and B minus B to A. Further going to C is given to blue, red, and green, where red is mixed to phase is mixed to the ground. Now the limitations of locus and assumptions. First one is locus of control, internal and external. These are divided into internal, external. We if external factors are involved in counting the locus, and internal factors are also involved in the mobilizing the locus diagrams. Assumption. First taking the assumption, dual locus diagrams are really on the assumption in independent assortment of unlinked genes. Then the interface genes means they have taken the two axes of RL and RC. Interface, the occurrence of the crossover event in the influence of linkedhood of an another crossover event nearby. It is called as interference. Means the two axes are crossed that equal to 0, XL equal to X equal to 0. Then it is a locus of interface. Third one is the data limitation, accurate data limitation in the sizes of the experimental data as we know. Now coming to the conclusion of the locus on dual networks of locus diagram, the depiction shows that the probable locations of the poles and the feedback system. This represent shows the possible locations of the poles and the system whose different values of the parameters. The angle condition can be satisfied by all points as the components of the root locus diagrams. Hence, we have explained all the types of locus diagrams and its application by taking an example of RL circuit locus diagram. Thank you.